Have you ever looked up at the stars in the sky and dreamt of one day being able to visit them? What you're actually seeing is the light that was emitted by them thousands or millions of years ago, and they've covered huge distances just to reach our gaze. Light is, by far, the fastest traveling thing that we know of. But could we one day travel faster than it? Science fiction has created many ways to make this possible, like a warp drive. But in real life, what do physicists have to say? For a long time, it was believed that light traveled instantaneously. It was only in the 19th century that scientists were able to prove it actually had a speed. It's so fast that it was very difficult to accurately measure, but we now know that in a vacuum, light travels at 186,282 miles per second. This is not an easy number to understand, so to put it into perspective, if it were possible to travel at that speed, you would be able to go around the Earth 7.5 times in just 1 second. There are things in the universe that can affect the speed at which light travels. Passing through gases or even water can slow it down, and its behavior completely changes in the presence of a black hole. This variation is why the maximum speed of light is referred to as c, with altered speeds represented as fractions of c. The speed of light is integral to Einstein's theory of special relativity, first published in 1905. The equations behind this are incredibly complicated, but the basic principle states that light will travel at the same speed no matter what the velocity that you as the observer are traveling yourself. This means that whether you're standing still on the Earth's surface or in a plane flying at high altitudes, your measurement of its speed will always be the same. Einstein discovered that no matter the time or place that you are in, the speed of light doesn't waver. This is the theoretical speed limit of the universe, and nothing is supposed to travel faster than it. The theory states that this is because as an object increases in speed, its mass also increases and its length reduces. Therefore, at the speed of light, the mass of any object would be theoretically infinite, while having a length of 0, which is impossible. Assuming this theory is true, the speed of light would therefore be impenetrable and never breached. That is, apart from light itself. Quantum physics describes light as a packet of photons, which are massless particles and able to reach this maximum limit, but even they are unable to go any faster. But you might ask, does this mean we'll never be able to travel to distant stars? Just because the speed of light is a theoretical maximum, it doesn't necessarily mean that we won't be able to develop interstellar transport. The closest stars to Earth, Alpha Centauri A and Alpha Centauri B, are about 4.3 light-years away. Even if we were able to reach half the speed of light, the journey would be possible in less than 10 years. Of course, the fastest object ever made by man is the Juno spacecraft, which travels at 25 miles per second. That's less than 1/7,000th of the speed of light, so we still have quite a way to go. There are a few theories of how speeds faster than that of light can be achieved. As we said earlier, light travels at 186,282 miles per second in a vacuum in normal space. But if there was a way to fold space-time in a bubble around the spaceship, then it may be possible to circumvent the traditional laws of the universe. Rather than traveling in a straight line across space, this would give us a shortcut through it. It wouldn't technically be traveling faster than light, but taking a more efficient route, so you would be able to reach the destination in a shorter amount of time. As with everything, there are some exceptions to the rules that are set by the theories of special relativity. The most interesting, perhaps, is that special relativity only applies to things that are nearby, and not to galaxies on the other side of the universe. In these cases, the theory of general relativity would apply, and it allows for much larger speeds to exist. Take the expansion of the universe, for example. This happens at the most minute level, so the further away a galaxy is, the faster it's moving away from us. A galaxy that lies 1 megaparsec, or 3.26 million light-years away, is distancing itself from us at about 40 miles per second. But one that lies 2 megaparsecs away is distancing itself from us at about 80 miles per second, because there's twice as much fabric of space that's expanding. This means that a galaxy that's a distance of over 15 billion light-years from us will be traveling away at more than the speed of light. While this doesn't necessarily help us in moving any faster, it shows us that there are theoretical ways to breach the limit that don't involve completely rewriting the rules of physics. One day, it may be possible to harness this to our own benefit and cut that journey time to Alpha Centauri down to just 4 years. If we ever intend on visiting other star systems, a means of faster travel will need to be developed. Within our current understanding of physics, the speed of light is the absolute limit, and we would experience serious problems getting anywhere close to it. As technology stands today, we probably won't witness this in our own lifetimes. Except, of course, if a warp drive button were to be found. Thanks for watching! Let us know what you think in the comments below. If you enjoyed this video, hit that like button and check out some of our other videos on the right. Don't forget to subscribe to our channel so you don't miss our newest episodes, and we'll see you in a flash.